Hey everyone, today I'm going to show you how to build a really fun automatic push-up counter. It'll be great for working off those quarantine pounds. So let's get to it. What you're going to need is an LCD screen, a Q-Client builder base, a distance sensor, and this part's optional, but we're using our 5-volt power supply DIY kit to power this build. You can also use a micro USB cable. Either is acceptable. You'll also need 12 male to female jumper wires and 2 male to male jumper wires. So now we'll get started by assembling the circuit. We'll start with the LCD. And so you're gonna take your LCD in 4 of your male to female jumper wires, and you're gonna start by putting the ground and the power wires onto the LCD. So we use black and red for ground and power. So we're going to connect the black male to female jumper wire to the ground pin and the red male to female jumper wire to the VCC pin. And then we'll use orange and white for the SDA and SCL lines. In this instance, we're going to use orange for SDA and white for SCL. And then we'll go ahead and connect the ground lead to one of the ground ports on the builder base. And then we'll connect the VCC line to the 5-volt port on the builder base. And I lost an LED. And the SDA line to the SDA port on the builder base. And then the SCL line to the SCL port on the builder base. All right, once that's done, we'll go ahead and connect the HCSR4 distance sensor to the builder base. All right, so with the distance sensor, we'll take another 4 male to female jumper wires, and we'll go ahead and connect those to the pins first. Then we'll wire it up to the builder base. So again, we're going to be using red and black for ground and power. So connect your red line to the VCC pin and your black one to the ground pin. And then we're using green and yellow for trigger and echo. And so we're going to use green for echo and yellow for trigger. So now we're going to go ahead and connect this to ground and power first. Just take your ground line and connect it to one of the ground ports. And then take your 5-volt line or your VCC line and connect it to the 5-volt port. Okay, so now we have trigger and echo. We're going to connect the echo line to GP2. And the trigger line to GP3. Now we'll go ahead and get started on the LEDs. So we'll do the green LED first. What you're going to need are 2 more male to female jumper wires. And so on these LEDs, you can see that there's a short pin and a long pin. The short pin goes to ground and the long pin will go to one of your GP ports. In this instance, with the green LED, we're going to use GP0. So go ahead and attach your male to female jumper wires. And then we will connect the short leg to ground. And the long leg to GP0. All right, now we have to do the red LED. Once again, grab 2 more male to female jumper wires and attach them to the legs, noting the short leg. And again, we'll start by connecting the short leg to one of the ground ports and the long leg to GP1. All right, now finally, we have to connect our power supply. If you're not going to use this power supply, you can skip this step, but we're using one, so we need to connect it to our circuit. So take 2 male to male jumper wires. We're using red and black. And we're going to connect the red line to the V plus port on the power supply and the black line to the ground port on the power supply. Okay, so now go ahead and connect the ground line to the last remaining ground port on the builder base. Then connect the V plus line to the 5-volt port on the builder base. All right, so now once all that's wired up, when you flip on your power supply, your client LED should illuminate. Okay, great. So now that that's working, we're going to go ahead and build the firmware and then the application, then we'll test this project out. So we're going to head on over to our computer, load up your server homepage, and we're going to navigate to the firmware builder. Once you're at the firmware builder page, select the create new button, and we're going to name this one push up counter. From here, select the add hardware button, and we're going to start with the LEDs. We'll name this first LED green, and then the next LED red. Whoops. All right. And then we'll add a distance sensor and an LCD. All right, from here for the green LED, select the GPIO driver, set the pin to GP0 and the mode to initially low. For the red, select GPIO as well, select GP1 for the pin and set the mode to initially low. For the distance ultrasonic sensor, select the HCSR04 driver, set the echo pin to GP2 and the trigger pin to GP3, and we'll leave the resolution at 5 centimeters. If you want to change your units from metric to imperial, you can do that in the settings page as well. Just a side note. And then for the LCD, go ahead and select the generic LCD2004 display I2C driver. We're going to set the I2C address to 0x27 and the layout to 2x16. Before you use your LCD, you should check to see what your I2C address is. You can also go into the debug page and do that there once your LCD is connected to your client. Okay, so go ahead and save that client. And you're going to want to make sure that the client you built this circuit on is already connected to your server. Once that's done, you can go ahead and upload this firmware to your attached client. So now that our firmware is uploading to our client, we're going to go ahead and navigate over to our application builder where I'll walk you through exactly how to build this application. So you're going to want to have your push-up counter application imported into your server. You can find this on our documentation pages, which are linked below. And they're described in much greater detail than we go into in these videos. So if you want, go ahead and check them out. So let's get started with walking you through the higher level programming involved in this app. So you can see here that we have our 4 hardware objects represented. We have our 4 devices connected to our client represented by these 4 hardware objects. So we have our distance sensor, 2 LEDs, and our LCD. And then we also have this initial trigger block. So now the way initial trigger blocks work is as soon as the application is started, that block triggers. So what we have it doing currently is our application starts, this block is triggered, which then triggers the static string block, and in the static string sends the string push-up count : which is then sent on over to our LCD. So this means that once we turn on the application, once we run it, the string push-up count will appear on the LCD. So then the next step in our app is we have this distance sensor, and this is obviously what measures the distance. So this is what will tell us if we've done a rep. And so we have these 2 value compare objects. One is comparing the value from the distance sensor to see if we've done the up portion once we're at the top of the stroke of the push-up. Then we also have a value compare object to detect if we've gone to the bottom. And so from the distance sensor, we have a connection that goes into the value 1 port for each of these. And then we have the value 1 port on both set to trigger. You can see that here. And so now the value 2 for the top is set to 35, and that's in centimeters. And the value 2 for the bottom is set to 5. So now that means that for the top of the stroke, if the distance from the sensor to your chest is 35 centimeters or greater, that means you've gone to the top of the stroke. And so now once that happens, once it's greater than or equal to 35 centimeters, the value compare object triggers the digital toggle object that it's connected to. So now what that toggle does is it sends a signal to the AND object. And then, so once you've done the bottom stroke, the same thing occurs. So once you've gone 5 centimeters or closer to the distance sensor, the value compare object triggers the digital toggle object. And so once both of these toggle objects are triggered, the digital AND object triggers. And so now once that triggers, it sends a signal to this data counter to increment the count of the push-ups. And so if you've started at 0, it's incremented by 1. Now you've done 1 push-up. So with that happening, simultaneously, the digital AND object triggers the timeout object, as well as triggering the digital toggle object. So once the AND object is triggered, the digital toggle object triggers the 2 LEDs. So the red is on normally. Once you've done a push-up, the LEDs will switch so that the green is on and the red turns off. And that happens for 700 milliseconds because of this timeout object. Because these 2 objects are triggered simultaneously, this toggles, and then 700 milliseconds later, the digital toggle object is reset. So it goes back to its default state with red on and green off. So now going back to this increment object, once this is triggered in the count of the push-ups is incremented by 1, it sends that value to the LCD here. So it sends it to the string port, and it also sends it to the send to display. So that's just being used as a trigger. So it's sent to the string port, and then the send to display port is triggered. With that, simultaneously, this static number object is triggered, and this value is set to 14. And so this is the column position value. So that goes into the column position value. So this means that the number will be rendered on the 14th square of the LCD. And so we send that so that the number, once it's updated, is sent to the same position every single time. So that's the basics for this application. Again, if you want to learn about this application in greater detail and you want to build it step by step, go on over to our documentation page, which is linked below. You'll be able to see perfect instructions on how to build this project, as well as all of our other projects. Okay, so now with this application done, we're going to go ahead and map it, and we're going to actually see it running. So to map it, return to your applications page and hit the play button next to the push-up counter app. We're going to map the green LED to the green LED that's connected to our client, the LCD to the LCD that's connected to our client, the distance sensor to the distance sensor, and the red LED to the red LED that's connected to our client. Once you've mapped every single device, go ahead and hit Save plus Run. And now you should see on your LCD, it says push-up count colon. So that was initially triggered by the initial trigger in our application. So now once we cover the distance sensor and remove our hand, you can see that the count is incremented by 1, and then the green LED toggled on for 700 milliseconds, and then the red LED took over and toggled on for default. So now we can do that one more time. And there you have it. That's our application, and that's our project. Now we're going to go ahead and show you the push-up counter that was put into one of our 3D printed cases. And we're going to actually show you this thing in action with us doing some push-ups. We hope you enjoyed this video. If you did, consider leaving us a thumbs up and check out the other videos available on our YouTube page. That really helps us out. So thanks for watching and have a great day.